Hello friends, welcome to Susan and John MathTube. So in this video we are going to do problems related to gradient, and I'm going through only selected questions which came in the past year question papers. You can also confirm with the past paper questions. Okay, so one type of question that I saw in gradient was they were asking directional derivative. And another type of question I saw is they are asking angle between two surfaces. Anyway, I saw this question right now. Let's start from here. So look at this. You have to understand angle between any two surface. Let's say phi equal to 0 and psi equal to 0. Is given by cos inverse modulus of n1 dot n2 by mod n1 mod n2. Now remember, this will give you the acute angle because we are making sure that the quantity inside cos inverse is positive. If you want the obtuse angle, all you have to do is 180 degree minus theta. But if they do not specify, it's enough to leave it as such. Okay, so remember, angle between any two surface is given by these two formula, where n1 stands for the gradient of the first surface and n2 stands for the gradient of the second surface. Do you remember I told you, or if you have learned planes, you might understand a little bit. If you want to measure the angle between two planes, what we do is we measure the angle between their normals. So remember, gradient is actually the normal to the surface at any random point. So if you want to find the angle between the surface, it is enough to find the angle between the normals. Okay, so let's do one question. Find the angle between the sphere x square plus y square plus z square equal to 9 and the surface z equal to x square plus y square minus 3 at the point 2 minus 1 2. So look at this. They can even ask the question like find the angle between the normals. So remember, angle between normals and angle between surface is the same. So the first thing to do is you have to write or rewrite the surfaces. So you can write like this. The given surfaces are, the first one is a sphere, but you have to put it in the form is equal to 0. And the second one is x square plus y square minus z minus 3 is equal to 0. So look at this. This is our phi equal to 0 and this is our psi is equal to 0. So I'm going to write that is, so what is the value of phi? Remember, angle between any two surface is the angle between their respective normals. And the normals are given by gradient of the function. And one more thing, I told you in the last video, gradient is defined only for scalar valued functions. So now I'm going to find gradient of phi, which is del phi, and which is given by the formula. In examination, make it a habit to write the formula. Okay, so we get I. Tell me, what is the partial derivative with respect to x? Yeah. Plus j plus k, and here I am going to calculate gradient of psi. In examination, write del psi equal to, but I am going to write the answer I. What is the partial derivative? 2x plus j, partial derivative with respect to y, plus k, partial derivative with respect to z. So we got the normals. But remember, Gradient stands for normal at any random point of the surface. We need two particular normals. Look at this, they are asking what is the angle at this particular point. So I am going to write, let n1 and n2 be the respective normals at 2, minus 1, 2. So what will be n1? You have to find gradient of phi at that point. So 2 into 2, 4i minus 2j plus 4k. And n2 means the gradient of psi. Yeah. Now I have to plug in the point over here. So I get 4i and then minus 2j minus k. What is the formula for angle? Acute angle is cos inverse modulus of n1 dot n2. How do you find the dot product? Yeah, multiply 4 into 4 plus minus 2 into minus 2 plus 4 into minus 1. The whole divided by modulus, that will be root under 16 plus 4, 20, 20 plus 16, 36. That will be 6 and root under 16 plus 4, 20, 20, 21. So that's it, you simplify and keep that answer. Okay, now I saw another question which is very similar, which you can practice by yourself. Okay, that was asked in 2075. Okay, the question is find the angle between the normals. Basically they are asking to find the angle between the surface, and the surface is given by x log c equal to y square minus 1 and x square y plus z equal to 2. I saw a very similar question in 2077, I guess. The only difference was instead of 2 they asked equal to 0. And the point is 1 comma 1 comma 1. Okay, so what is the first thing to do? Yeah, take everything to the left side and call it phi. And what's the next surface function? X square y plus z minus 2. Now what you do is you find the gradient of phi. In examination, write the formula del phi, etc., etc. But to make things easy for you, I will give you the derivative. The partial derivative with respect to x means it will be log z times 1 minus 0 plus j times. Now you differentiate partially with respect to y and then differentiate partially with respect to z. That will be x is a constant, x by z. And what will be grad psi? Okay, differentiate with respect to x. So it will be 2xy plus j into x squared plus k times, what will we get? Yeah, 1. Okay, and then proceed and you can find the answer. You can comment down the comment section about the answer, so it will be helpful for others. I guess it should be cos inverse 1 by root 30 or something. I had a rough calculation here. Okay, another question I saw in a question paper is, okay, find the angle between the two normals of xy minus z square equal to 0 at 1, 4, 2 and minus 3, 3, 3. So look at this, the procedure is 100% similar. You have to understand the fact that the gradient of a function, so what is the function here? Xy minus z square. So remember, the gradient of a function gives the normal at any random point. And what's the gradient? I times differentiate with respect to x, so that will be y, plus j times differentiate with respect to y, that will be x, and plus k times minus 2c. Yeah. So this is the gradient. Now n1 means the gradient at the particular point 1, 4, 2. So you plug in x is equal to 1, y is equal to 4 and z equal to 2, you get n1. And n2 means the gradient at the particular point minus 3, 3. And the same procedure. Anyway, I ended up with cos inverse 1 by root 22. Confirm the answer. One of the most repeated question. Okay, find the directional derivative of the function. Find the directional derivative. This is one of the most repeated question. xy plus yz plus zx at the point in the direction of I plus 2j plus 2k. So the first thing we do is we make sure all the functions have proper name. Anyway, I already called the first function as phi, and the direction in which we have to find, we are going to call I plus 2j plus 2k as a, and the point is 1, 2, 0. So what do you mean by directional derivative? Of course, the gradient. So we have to calculate grad phi. That will be I. In examination, write the formula. Grad means del phi. Del means I dou by dou x, etc., etc. So the partial with respect to x will be y plus 0 plus z plus j times x plus z plus k times 0 plus y plus x. Okay, so what is the gradient or the directional derivative at 1, 2, 0? What should you do? You have to put x equal to 1, y equal to 2, z equal to 0. I got 2i plus j plus 3 times k. Okay, now look at this. We want the directional derivative in the direction of A. So what do? We take the projection. So I am going to write required directional derivative is grad phi dot unit vector along A. That will be A divided by modulus. And that will be 2i plus j plus 3k dot product with A, that is I plus 2j plus 2k divided by modulus. How do you find the modulus? Root under 1 plus 4 plus 4. And we learned in vectors, you can keep the number, the scalar, the denominator is a number, right? It's going to be 3, so I'm going to keep 1 by 3 here. And I'm going to do the operation dot product with blue and red, blue and green. So we get 2 into 1, 1 into 2, 3 into 2, add them up. I got the answer 10 divided by 3. Okay, now I'll show you another question that I saw in a question paper. This question has been asked many times. Find the directional derivative of the function. Now don't get scared when they give phi of x, y, z. They simply want to say phi is a function which depends on x and y and z. If you don't like this notation, in examination you can simply call it phi is equal to. So the function is x y squared plus y z cube. I saw this same question being repeated many times at the point, but the point was different in different question papers. In the direction of I plus 2j plus 2k. So you know the procedure. First you find gradient of phi. So we get the directional derivative in general. Then you find the directional derivative at 2 comma minus 1 comma 1, and then the required directional derivative will be grad phi dot a by mod a, where a is given by this function. Okay, now one more question that I saw in a very old question paper is They have not asked this recently. They have given three functions. F is x plus y plus z. G is x squared plus y squared plus z squared. And h is xy plus yz plus zx. And they are asking you to calculate the scalar triple product of grad f, grad g, grad h. So it's very easy. Grad f, that's the gradient of f, is del f, which is, you know the formula. So it is given by I, partial derivative with respect to x is 1, j plus k. And gradient of g, that will be del g, is I, you get 2x, plus j, you will get 2y, plus k, you will get 2z. And gradient of h, del h, be careful with the differentiation. When you differentiate with respect to x, you have to understand x is here and here. So we end up with y plus z plus j times z plus x plus k times x plus y. Now we want to find the STP, and I told you many times, to find the STP when we have vectors in component form is the determinant method. So what I do is I take determinant 1, 1, 1, 2x, 2y, 2z, y plus z, z plus x, x plus y. You can expand it in any method. Anyway, I am going to use the property. I am going to take this 2 outside. So you get 1, 1, 1, x, y, z, x, y plus z, z plus x, x plus y. So 2 will be here. And now I am going to add R3 changes to R3 plus R2. So I can see something common coming up. That's why I'm doing that. Can you see? X plus y plus z, x plus y plus z, x plus y plus z. And this will come. You don't have to use properties. You can use any method which you prefer. Anyway, I love properties of determinants. That's why I'm using this method. So here we go. The answer is 0. What's the reason? Because two rows are identical. Okay, now one more question. So they are asking, find a unit normal vector for the surface z equal to x squared plus y squared at the point -1, -2, 5. Now look at this. This is very easy to solve. What is normal to any surface at any point? The gradient. So how do you find the normal vector? Find the gradient. Now you know how to make a vector into a unit vector. Divide by the modulus. Okay, so the first thing is take everything to the left or right. Anyway, I'm going to write the surface as x squared plus y squared minus z equal to 0. So that my scalar generating function or the surface generating function becomes, okay. Now I'm going to find the normal vector. What's a normal vector? Of course, the gradient, which is del phi, which is the partial derivative with respect to xi, etc., etc. So that will be I into 2x plus j times 2y plus k times -1. And now we are going to find the normal at the particular point at -1, -2, 5. The normal vector will be -2i, -4j, -k. Now unit normal vector, that's a cap vector, hat vector. So -2i, -4j, -k, whole divided by root under 4 plus 16 plus 1. Complete the calculations. One more question. It's kind of like very simple. They're asking, okay, they're asking you to find gradient of r to the power n. Now look at this. These are very important type of questions. First of all, you have to understand if R is not defined, what we do is we take the vector R to be the random position vector for the random point x, y, z. So that R will be the modulus. I hope you remember in vector notation A stands for a vector, and simply writing like A stands for the amount, the magnitude, the modulus of the vector. So basically if R is xi plus yj plus zk, then the modulus will be root under x square plus y square plus z square. Now you'll see so many problems related to this in the books in which you can see vectors. So the next thing you have to do is you have to square on both sides. Not only in this problem, there will be many related questions. I am doing one question that I found in an old question paper. Now what you do is you differentiate partially with respect to x. In partial differentiation videos, I told you if you have an expression like this, then these are the independent variables and this is a dependent variable. So we get 2r, the partial derivative of r with respect to x equal to 2x, which eventually gives me dou r by dou x is equal to x by r. And because of symmetry, I'm not going to do the other stuff. I'll get the partial with respect to y to be y by r, and the partial derivative with respect to z will be z by r. Okay, now we are ready for gradient of r power m. Come on, tell me, what is gradient of r power m? Of course, del r power m. And that will be I dou by dou x of r power m plus j dou by dou y of r power m plus k dou by dou z of r power m. Now remember, r is a dependent variable. So when you differentiate, you have to write m r power m minus 1 times dou r by dou x. Don't forget this. Plus j m r power m minus 1 dou r by dou y plus k times m r power m minus 1 dou r by dou z. But we already know these values. So I am going to plug in those values. M r power m minus 1 x by r plus j m r power m minus 1 y by r plus k m r power m minus 1 z by r. Now let's use laws of indices. A power m by a power n is given by a power m minus n. So we end up with I m r to the power m minus 2 into x plus j m r to the power m minus 2 into y plus k m r to the power m minus 2 into z. And that gives me something common, m r power m minus 2. And can you guess the remaining vector? Xi plus yj plus zk. Come on, how did we start? I told you, in all such problems we take, so the final step will be gradient of r power m is m r power m minus 2 into r vector. Now take any book which you like and do a lot of problems related to R. You will find a lot of problems related to R. They are very, very important in exam. I just gave you one model to show how to do these problems. Anyway, I'll back with another video very soon. So till then, my friends, bye.